record and share my screen. And we're going to get started. So today we're going to talk about graphing lines using slope-intercept form. So what was our, I'll come back to the screen, guys. What was our slope-intercept form? Anybody can answer it on Zoom or in here. I'd like more of you in here to answer. What is it? What is slope-intercept form? We talked about it a lot. Nobody knows? How do we write equations? What does our equation look like right now? When we write it, what do we start it with? Y. And then what comes next? Equals M. Keep going. X plus B. That's our slope-intercept form. That's what I'm asking. Yeah, so it's not anything you didn't know. You just might not have known that it's slope-intercept. So Y equals mx plus b. And those of you on Zoom, I've told everybody in here, once you come on Thursday, those of you that are supposed to come, you will get copies of these notes, and you will get copies to last you through the next time I see you, okay? Who is chatting me? Yes, Hector, it will be at this time every day because we have to eat lunch. We eat lunch at 12:08-ish, so I give them their time to eat lunch. So yes, every day, 12:40. All right. So which one is your slope? Which one represents slope in that y equals mx plus b? And honestly, the coefficient is just the m, okay? The x just reminds you that that's where it's at, okay? The y-intercept or the constant, which one represents the y-intercept? Or where you start? The b, yeah. Okay, so remember that m is the slope, and the b is the y-intercept or where you start. So as long as you can remember one of those, you'll be fine. What is an x-intercept? What's an x-intercept? We talked about it. We had to find them. We had to graph them. Remember when we graphed on the x and the y-intercept? Do you guys remember that? No? The y-intercept is where we start. How do we put it on the graph? Where does it go? But where on the graph? Anybody can answer. If we have this graph right here and I tell you to start at 4, where would you graph it? Say it again. Where though? On the y-axis. So a y-intercept crosses the y-axis. So what would an x-intercept do? Cross the x-axis. Very good. All right, so to find the slope, this has some crazy stuff right here. This is the same thing as rise over run. And then to find the y-intercept, remember it's where we start, okay? On the next part, all I want you to do is identify the slope and the y-intercept. The slope is also called the coefficient because it's the number in front of the x. The y-intercept is also called the constant because it doesn't change. We always start there. What changes is the slope. Okay, so look at this first one. Which number represents your slope? Just the 2. Don't put the x with it, just 2. Which one represents your y-intercept? 3, that's it. Very good. On number 2, which one is your slope? -2, very good. I like hearing all y'all talk, thank you. And then the y-intercept? Perfect. And then on the last one, be careful on this one because if we look at it, where's our slope? We don't have one. So this one doesn't have a slope. This one doesn't have a slope. Does it have a y-intercept? Yes, what is the y-intercept? Okay, remember, and that's because it is y equals. If it were x equals, what kind of line would it be? Y equals is no slope, so that means it's horizontal. Does everybody remember that? We can ski on no slope. Not really, we got to work really hard, but we can still stand up on it. What's the one we can't stand up on? What's it called? Is it vertical? But what kind of slope does it have? Undefined. Don't forget that. So if it were x equals, so I'm going to put that on there. X equals is an undefined slope, not zero, undefined, because we can't ski on that. We'll die. We talked about that. All right, so we're going to talk about it again right here. If you have a positive slope, that means you have a positive m, and it's going up and down. You are positively going to work hard if you have to ski this slope, right? It's hard to ski uphill, right? Okay. You will have negative work to ski downhill. You don't have to do any work to go downhill, right? You can just stand there and you're going to go. Zero slope. If you're on flat ground, you have zero movement. Zero movement. And if you look, the equation is going to be something like y equals 4. Y equals -2. And then if it's undefined, that means we can't ski that at all because we're going to die. Literally, that's what you would do. Like, I'm not trying to be, usually that'll help you remember. So undefined is going to be something like x equals 9, x equals -1. So you cannot ski that. All right, we're going to flip it over. I'm not going to use that graph at the top at all. If I go too fast, you guys tell me to slow down. That's not a problem. I'm not going to get upset. And then we're going to take this graph right here and we're going to identify these key parts, these very key parts. So the first thing is, how do we find the slope of a graph? We've already done this. This is all review. How have we done it? You make your box. And this one's hard to see, but we're going to knock it out. What's it look like? That's what happens when y'all aren't on time. That's why I always say be on time. What's it look like? What's our rise? What's our rise? Just 5, right? We'll talk about positive and negative in a minute. What's our run? And then you decide if it's positive or negative. Since this one is going down, it is negative. So we put a negative on the 5/5. What does that reduce to? So our slope is -1. Where did we start? Where do we start? Remember, that's our y-axis. Where does it look like we started? Look hard. Sorry. Do you see 3 or 2? I see 2. They're hard to see, so it's not, you can count. So knowing the slope and the y-intercept, remember we have the equation y equals mx plus b. We've been doing this for a little while. M is your slope. B is your y-intercept. How can I write the equation in this line? Y equals -1 what? X plus 2. Great job, both of you. Great job. Is there a better way that I can write that? I'll accept that answer. Y'all realize I'll accept that answer. That's not a wrong answer. Is there a better way to write it? Perfect. Either one of those is perfect. Don't freak out too much about it, okay? It is perfect. If it's multiple choice, you'll see the bottom one. If it's free response where I have you type it in, you can put the first one or the second one. It'll come out the same way, okay? All right, so your x-intercept is where it crosses the x-axis. That's right here. Where does it cross the x-axis? 2. So then it's asking if it's increasing or decreasing. If this graph is a negative graph, is it increasing or decreasing? Decreasing. I am not worried about discrete or continuous. This one is continuous because it doesn't stop. We don't really work with anything but continuous graphs, okay? So don't stress out about that at all. And then we need to find the domain and range. So the domain, when we were doing number sets, like relations, we were just using all the x coordinates. Well, the thing with this graph is it goes forever to the left and forever to the right. Does anybody know anything in math that we can use to describe forever? Infinity. Is everybody good? But if it goes to the left, what kind of values are on the left side of this graph? Negative. So your domain on the left, it's always left to right, is negative infinity to positive infinity. Linear equations will always, listen carefully, they will always be negative to positive infinity as long as they are continuous. The only thing we work with right now are continuous graphs, okay? So then your range is how low to how high it goes. How low does this graph go? Where does it point to? Does it ever stop? So where would it point to? Infinity. And if it's on the low end, what would we call that? What kind of values? Negative. It is also negative to positive infinity. We're going to do the same thing on the next one. All right, you can see this one a little bit better. You can see all your little dots. So we're going to come up with our slope. 1, 2, 3, 1, 2, 3, 4. So what's your rise? And your run is 4. Is this one positive or negative? So your slope is negative 3/4. Where did it start? Where is your y-intercept? Negative 2. So that makes your equation? Perfect. Very good. Negative 3/4 x minus 2. X-intercept is where it crosses the x-axis. So remember, this is your x-axis. We're going to find it crosses right here, and it is at negative 3. Is this one increasing or decreasing? Why is it decreasing? It is negative. We're not worried about discrete or continuous, but we do know that this one is continuous because it doesn't stop. If it doesn't stop, what is its domain? Make sure you put the negative first. And then what's the range? Negative to positive infinity. That will not change until we change the domain, until it's not continuous. Is everybody okay? So those are the things that you can pull from the graph. We want to pull the slope, the y-intercept, so we can write our equation. And then we have some x-intercepts. They're not real important all the time. They will be soon. And then domain and range. And that's what we're doing. So we're going to keep doing this. We're going to do it one more time. I want to do it with a positive graph. This is the only positive graph that we have here. How do you know it's positive? It's going up. All right. So we're going to count our boxes. Looks like 2 and 8. We're going to say it's 2 and 8. How about that? So what's your rise over run? Which reduces to 1/4. I do want you to reduce them. If you can't do it, your calculator will. Remember, hit math, enter, enter. So your slope is 1/4 and it is positive because the graph goes up. You will positively work hard to ski up this graph. What's your y-intercept? Where did it cross the y-axis? Somebody else. What's the equation of your line? Perfect. Well, this one's kind of hard because it doesn't show your x-intercept. I'm going to hold off on that for just a few minutes, okay? So we're going to mark that one out on this one because we can't see it right now. How could we find it? Keep doing your slope until it crosses. But this graph is too big, like it's too much over there, and I don't want you to get confused, okay? So we always want to look where it crosses. If we don't have it, we just keep going with our slope. Is it increasing or decreasing? Why is it increasing? Good, it's positive, so that means it's going up. We don't worry about that, but it is going to be continuous. Even though it's positive and not negative, how far does it stretch left to right? If it's got arrows, negative to positive infinity. Top to bottom, negative to positive infinity. We're going to skip number 4. And we're going to move to the next part. All right, so what they want you to do is plot all these points, but we already know how to do that without having to plot the points, so we're going to look at it in just a minute. So how would I graph this? Where would I start? And then I would do my rise over run. And how do I make this 2 into a fraction? So my rise over run. So we're going to start at -3, and this is a really good graph. You can see it. And we rise 2, run 1, and we keep doing that all the way across our paper. And then all this table wanted you to do is fill in the table, like plug it in. That's too much work. I don't want you to plug it in and take all that time. But we can graph these points. What's your point at -3? So if I go over to -3, see how it's off the graph? I don't want to do that one. At -2, still off the graph. I don't want to do that one. At -1, what's my coordinate? -1, what? What kind of 5? -5. What about at 0? 0, -3. 1, yeah. And then 2, +1, and 3. I'm not going to make you do that chart anymore. Here's why I'm not going to make you do it. If it's on your homework, this is how you can do it. Go into your calculator, into y equals, and I got some crazy stuff in there right now. But put your function. Our function was 2x minus 3. When you put that into your calculator, you can go to second graph. Remember, I record these notes, so if you forget, you can go back and watch it. Second graph, and you can get all those. So at -3, we should have had -9. At -2, we would have had -7. You guys see that those are the same coordinates. So -1, -5, 0, -3, 1, -1, 2, 1, and 3, 3. So you don't have to, you can use your calculator. I don't want you to do anything but use your calculator. I don't want you to plug it in, okay? So if we're doing this one, I don't want to graph this one. I'm going to look at just the table to show you one more time. We're going to type it in, -3x plus 5. Your x key is right beside your green key. So alpha, you don't have to do alpha, but your x key is right there. I'm going to go to my table. And it says, what's at -3? You guys can look up here on the screen if you need to. What's at -3? 14. Somebody else, -2. Somebody else, -1. Guys, it's just reading. 8. Somebody else, 0. What is that point called? What's this point called? Up here, it was 0, -3. What's 0, 5? What's that called? This is 0, -3. What is that? What's it called when it crosses the y-axis? Anybody on Zoom? What's it called when it crosses the y-axis? What's that point called?
Y-intercept.
Thank you. It's the y-intercept. Is everybody good? That's okay. Don't forget. So anytime that you see, this will help you out later on. Anytime that you see x is 0, that's your y-intercept. Okay, so in a chart, if you see x is 0, that's your y-intercept. If we keep going, it was 1, 2, 2, -1, and 3, -4. So if you have this in your homework, you can use your calculator to fill in that chart. That's perfectly fine. How do we graph this? Where do we start? Where do we start? Look at your graph. 5 on the axis, y-axis, 1, 2, 3, 4, 5. That's why it's called your y-intercept. How do we move? Down 3, right 1. All right. Couple more things and we'll be done. Couple more things. All right. So it says determine if the point -1, 3 is on the line. So all you do is plug it in. Plug it in. Ready? This is your x and your y. So we're going to take this function 5x minus 2y equals 8. What is our x coordinate? No, what's our x coordinate? That's okay. What's your y coordinate? And we're going to see, does that in fact equal 8? Guys, use your calculator. Don't try to kill yourself to get this done. 5 times -1 minus 2 times 3. Did that give me 8? No. It gave me -11 equals 8. This point is not on the line. If they are equal, it is on the line. If they are not equal, it is not on the line. Okay, so check out the next one. We have 10. What's your x coordinate? -2. Then it says +3. What's your y? And we're going to see if that's equal to -15. So 10 times -2 is your x, plus 3 times 2 is your y. I'm just plugging into this equation. Let's see if it gives us -15. So from here, I'm going to use my calculator. 10 times -2 plus 3 times 2 gives us -14. Are those equal? Then this point is not on the line. What's our next equation going to be? I'm going to plug in for x and I'm going to plug in for y. So what is x? Plus 4 times, what is y? -5 equals -16. Plug it into your calculator. 4 plus 4 times -5. We got -16 equals -16. Is that true? Yes. So this point is on the line. Okay. Everybody good? Plug in to determine whether it's on the line or not. If it is not equal, it is not on the line. If it is equal, it is on the line. All right, just graphing. That's all we're doing. Just graphing. So I'm going to do a couple of these, but not all of these, because we should already know how to graph. We've been doing this for a couple of days, right? Okay. So on number 5, where do I start? -5. 1, 2, 3, 4, 5. So start at 5, -5. Your slope or your rise over run is -9. How do I make it a fraction? That tells me to go down 9 and right 1, but I'm going to run into the other graph. So what's the opposite way that I can go? Up 9, left 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1. And that's all I'm getting on this graph, and that is okay. That is okay. That's a really crappy one for that graph, but it's okay. We're going to do one more, and then we're going to move on. So I'm going to graph number 6. Y equals 2x minus 5. Where do I start? How do I move? Good. It is 2 over 1, up 2 over 1. up 2 over 1. You can keep going, or you can just go ahead and just make sure that you put arrows. Exercise 6, we've already done. So the thing that we haven't done is talked about what the actual name of it is. So on number 6, it says standard to slope intercept. So standard means X and Y on the same side. Sorry, that same looks crazy. X and Y on the same side. Slope intercept means we're putting in Y equals. So all we're doing here is solve for Y. Do you guys remember the 2 steps to solve for Y? We've already done this. How do I get Y by itself? What do I have to do first?
Subtract X.
Now this one, number 1, you're not going to subtract it, but we're just going to move it. So my steps, the first one is move X. So on number 1, I don't subtract it, but I do what?
Add.
Add it. Why do I add it? It's already negative. Yes. Add 2x to both sides. Your 2x cancels out. You get 3y. Bring that all the way down. Equals, and write it in the correct order, please, from now on. 2x and a positive 8. Always put that x first, okay? So that's your first step. Move x. The next thing we need to do is get rid of this 3. So we got to divide by the number with y. Divide everything by 3. And you guys did really good with this when you had to do it. Now this one, again, is going to leave you with fractions. If you can reduce your fractions, please reduce them. If you cannot, then don't. So 2/3 will not reduce. We're going to leave it alone. And 8/3 will not reduce. And it is perfect to leave it just like this. Okay. Look at number 2. First thing we're going to do is move x. How do we move x? Subtract 3. This is where you guys messed up right here. Make sure you bring the negative 4y down. Write your x first. It was a negative 3x and a positive 12. How do we solve for y? Divide everything by negative 4. That leaves you with y equals, what's a negative over negative? Positive 3/4 x. And then 12 divided by negative 4. Negative 3. That's it, guys. That's all you have to do. You're going to have to start being able to do that. If you don't know how to do that, we need to talk. All right? Let's check out our next page. So this one wants you to graph. So all you're going to do is solve for y and then do what we just did. Plot your y-intercept and then go to your slope. So let's look at number 9. It is x plus 2y equals negative 6. How do I solve it for y? First step is to do what? Move x. Subtract x because it's a positive. I get 2y equals a negative x and a negative 6. Don't change their signs, okay? Leave them like they are. Last step, divide by the 2. We get y equals, how do I rewrite this? This negative x over 2. Negative 1/2, very good. And then 6 divided by 2 is negative 3. Somebody else, how do I graph that? So this is your start. And this is your rise over run. So I go what ways? Down 1 and right 2. And you just keep doing that till you're across the graph and you connect it. That's it. So again, nothing new. We're just kind of putting everything together now. Okay, just kind of putting it together. I want to do number 11. And then we'll move on. So we have x plus 4y equals 8. How do I get y by itself? subtract x, move x. I get 4y equals, put the negative x first, and a positive 8. So this is, it's actually a plus. It's okay. That's why I rewrote it. You're okay. It's hard to see. I get it. You're fine. Last step is to divide by 4. We get y equals, how do I rewrite this x part right here? And then 8 divided by 4 is 2. What's this tell us to do? Start at 2. And do what? Down 1 over 4. Down 1 over 4, can't fit it, or up 1, left 4. Great job. All right, so the last thing on exercise 6, we've been talking about how lines have negative to positive infinity, domain, and range, okay? So the reason they have that is because those arrows on the end. Now, what happens if we make it a real life situation? All right, a real life situation. So if I'm buying shirts, what's the least amount of shirts that I can buy? Is it 1? 0. I don't have to buy any shirts, right? Can I buy -1 shirts? -10 shirts? But if I graph that equation, you'll see that it keeps going. But what we have is a practical domain. So that's what this is talking about down here, is with a practical domain, you have to put it in context of the problem. So it says a video store charges $10 for a rental card plus $2 per rental. So what is your practical domain? So your domain, X is your rental, your charge is your Y. So remember, your domain is X, your range is Y. And we'll work on this more. So if you don't get it today, it'll be okay. All right. What's the least amount of rentals you can buy? What did we just talk about? 0. Now, you can buy as many rentals as you want, as many as you want. However, you can only buy as many as the store has, right? So we don't really know our upper domain, so I'm going to put infinity. But when we get to our test, it will not be that way. What's the least amount of money you'll pay? What's the most you'll pay? It depends on what? How many you can rent. So we're going to put infinity here as well. Let's skip number 2 for a minute, and number 3, I'll put it in better perspective for you, okay? So always the losing ones or the decreasing ones will help you understand practical domain and range better. So a terrier weighs 30 pounds and is on a special diet to lose 2 pounds per month. 2 pounds per month. Okay, you ready? Let's start with our range. That's how much it weighs. What's the least amount the dog can weigh? Probably going to weigh more than that, right? If it weighs 0, it's probably dead, right? Okay, but we're going to say 0. What's the most it can weigh? Look at it. 30. He already weighs 30, and he's going to lose it. All right. So how many months, your X is months, per month, per money, per rental, whatever. Per month, what's the least amount of months he could lose weight? What's the max amount of months he could lose weight? Really, that depends on when he gets to 0, right? So we would have to graph that. You'll see we'll do a snowman one that's already graphed for you. And it's however this is to here. So we'll see it. We're going to go ahead and say infinity for the moment, but we're going to leave it at that. All right, look at number 4. Also the same thing, descends. I have about 4 minutes, so I'm almost done. So y'all don't stress out like I've been talking forever, okay? An airplane at an altitude of 3,000 feet descends at a rate of 500 feet per mile. Per mile. So per mile is your X. Altitude is your y. Let's just look at range and not even focus on domain. What is the smallest range or the smallest altitude this plane could be at? Somebody else, what's the highest altitude it's going to be at? Look at it one more time. 3,000. That's as tall as it can go because it's there now. It's at its max and it's going to descend. All right, so let's look at our domain for a minute, and I'm going to talk, and if we run out of time, you guys don't worry, we'll come back in. All right, practical domain. It says 500 feet per mile. How many 500s are in 3,000? How would I figure that out? How would I figure it out?
3,000 divided by 500.
6. Is everybody good? 6. So our practical domain. The least amount he could fall per mile is 0. So 0 miles to a max of, what did we just say? 6 miles, and that would put him on the ground. And again, it's better to look at it as a graph than it is anyway. All right, so that's all of our notes. I'm going to stop sharing, stop recording.